Today we will start a new topic, neural networks. Neural networks are basically inspired from human nervous system. We have neurons in our body which are affected to the stimulus, external stimulus like touch, heat, or any sort of sense. Like then that stimulus carries an information which is passed by the network of our biological neurons to the brain, and this entire system we call it a nervous system. So this concept is inspired from that only. Computer neuron is basically a input set in which bias and weights are added. For example, consider input 2, and we want the square of that number, right? So square of 2 is 4 basically, but the machine doesn't know that logic. We humans know the mathematics and we know the logic, but machine as a computer, it doesn't know the logic, so it has to predict that value. So in order to make the machine predict that value, which is 4, we need to give input as 2, and we need to add weights and biases of different values, and we change the weights and biases until the predicted value, which is 4, is achieved. So in order to do that, in programming we use non-linear functions. Non-linear functions are basically the derivative, second order derivatives, in which we put this non-linear function, and when we solve it we get gradient descent, which we will study in our next sessions. So the basic concept of this neural network is it takes input and it adds weight and biases, and the combination of these three, by continuously changing weights and biases and tweaking its value until we get the predicted value, which is 4 in our example, right? So in that way computer learns according to the input of the user and gives us the predicted values, which are close enough to the accurate value. So we will, in this video only, we will further do a coding of this same logic square. Simple Python code for demonstrating a simple basic level neural network which can predict the square of any number. I used NumPy in order to solve the equations, which are second order derivative equations, which we will study in our further sessions. So this is basically a code of that neural network. It's 64 line of code, and let's see the output in computer. So here if we run the program UI, following output do we get. So here the epoch is printed, which is at 0 epoch the loss function of this neural network is 213, which is way more number of loss, right? So we have to decrease this loss and bring it to 0, and when the loss is 0, then we can get the accurate prediction or a close prediction to the square of this number. So here there are it's showing 1800 epochs. That means this program iterates over 1800 times with the same function and gradient descent in order to determine a predicted values. So in our test predictions we passed input as 2, so square of 2 is it predicted 3.83, and square of 3 is 8.9, 4 is 16.29, and minus 3 is 9.40. Okay, so it understands by itself. It's a Python language, so it understands the minus value. When we square it, minus into minus, it becomes plus, so it gives the prediction in positive integer, right? So these are the closest values. We can get even more closest values if we tweak the learning rate and number of epochs. So this was the simple demonstration of neural